mister.
Hi Rehan, how are you?
Hi, mister.
Hi everyone.
Hello.
Hi Tarek, how you doing?
Good, good.
Good. How you? Are you studying at home?
No.
Good. Where are the rest of the students?
Don't know, mister.
At 12:05, I will mark the attendance.
Which time, mister?
After 3 minutes.
Assalamu alaikum.
Walaikum assalam wa rahmatullahi wa barakatuh. So in about 2 minutes, I will mark the attendance. So just wait 2 minutes. And after that, we will start.
And space. What the heck? Let's go. What the heck عليه. هذا وجهك سمكة.
Now, one by one, I'll mark the attendance because the time is up. After that, if anyone comes, he will be marked absent. So, first of all, Isa is present. Second, Jawad. Third, Father. Then, Rayan. Then, Muhammad Musa. Then, Tariq. Then, Asif. Then, Rehan. Then, Saud. So first of all, as area of cross section, area of this surface is given. Area of this red surface is given. So I think that what you need to do, you need to find its radius because it's very important. So h is height, that is 2 meters. That is here. And area is 3 meters square. And we know so if, I will repeat the name of everyone. If anyone is missing, you can raise your hand. Isa, Jawad, Khadir, Rayyan, Musa, Tariq, Nasir, Rehan, Saud, Saad, Ali, Marwan, Bandir, and Muad. Every one of you is in it. If anyone is missing, then raise your hand. Muhammad Tariq, you are in it. Rayyan, you are also in it. Yusuf, Yusuf, where is Yusuf now? Yusuf Jabir. Yusuf Jabir, you are at this part now. Okay. Yusuf, what is your full name? Yusuf Anas, Yusuf Mahmood. Yusuf, I can't hear you. Speak a bit louder. Yusuf Anas or Yusuf Mahmood? Yusuf Anas. Okay. Okay, Yusuf. Total of 17 students. Okay, everyone lower your hand. Yes, Yusuf Jabir, what do you want to say, Yusuf Jabir?
Nothing.
Okay, then lower your hand. Basil. Okay, we will start the meeting now. Okay. Now we are starting the meeting, and inshallah, we will today finish the lesson. What is mixture? So let's get started. Yesterday we were talking about it. What is a mixture? We basically went through the most part of it, major part of it, but some part was left. So let's start from the beginning, so every one of you gets a simple idea of what is a mixture. First of all, a mixture is a combination of two or more substances. If you mix different things just physically, it creates mixture. If you bring some different beans and legumes and you just mix them, it creates a mixture, because after mixing you can separate them out gradually or eventually. So mixture is a combination of two or more substances. Simple as that. Okay. We talked about the mixture of legumes and beans very thoroughly yesterday. What about the salad? Salad is also a mixture. Why it is a mixture? Because we have simply mixed different vegetables together. Saad, turn off your video. Okay, so we basically have mixed different vegetables together and different fruits together. We can separate them out, because if it is not a mixture, let's suppose we have created a new substance. It means if we are mixing like a carrot or spinach, it is creating something new. Then it is not a mixture. But if it is, all the components are maintaining their own properties. Like from the mixture, if I eat spinach, right? If I'm eating spinach, I can taste it. Saad, you will be removed if you write again, because I allowed the student to write, but I will see their name if they write. Right now, Saad wrote. So this is a strike for you. If you write again, then you will be out of the class. Okay. So yes, if we eat a single component from the salad, we can taste its all the good things and the bad things in it. Right? If you are eating carrot, you can tell that it is a carrot. even if it is a mixture or it is put separately. Jawad, you are going to be removed. Then if you eat a potato in the salad or anything that you have put in the salad or onion in the salad, you can taste it, right? You have not created something new by mixing different vegetables. All of them, all the vegetables in it will keep their identity, will keep their integrity, right? Another example is sand and water. If you mix sand and water, right, it makes a mixture. It makes a mixture. If you keep it moving, the water in a circular form, the sand will be mixed thoroughly in the water. But if you allow the water and the sand mixture to sit for few seconds or few minutes on a table, then you'll see all the sand will settle down at the bottom, right? Now you can separate the water and the sand from each other. This is also example of a mixture. Then sugar and water, right? If you have sugar and water, then you mix these two things. Now you have created a sweet tasting water, a sugary water. It is also a mixture. Why it is a mixture? Because you can separate water from sugar. How can you separate? Simply by putting the mixture into a relatively hot environment. What will happen? Gradually all the water will be evaporated, but the sugar will be remained at the bottom, right? So all the water will be evaporated, but the sugar will remain at the bottom. Same thing with the salt and water solution, right? Or salt and water mixture. When you mix salt and water, what is happening? That you are creating a saltish water, right? You can taste the water now. It has become saltish. When you put it in the hot environment, what will happen? All the water will evaporate, but the salt will be remaining at the bottom of the container. You can separate the salt from the water. Okay. Then there's a term written here. This is called solution. This is called solution. Yes, South. South.
Mr.
Yes, yes.
Is the sea a mixture
Yes, yes,
of
South. Good
salt
point.
and water?
Good point. Yes, it is a mixture. It is a mixture. It has a lot of salts in it. Not just a simple sodium chloride salt that you eat at home. It has different hundreds of types of salts in it. So it is a mixture of hundreds of different salts and water. Plus, it also has oxygen and carbon dioxide in it. So it is a mixture of multiple things. Yes, South. Now lower your hand. Don't move your hand up without any reason. If you do that, then this is a strike to you too. Okay, Ali, without any reason, or Rayyan, without any reason, don't raise your hand. Yes, Rayyan, now ask.
Mister, I have a question.
Yes, Rayyan, ask. That's why I'm mute.
Rose can have two mixtures.
Sorry.
A rose.
Again, ask again. What did you say? I couldn't hear you.
I said a rose can have mixtures.
A rose?
Yes.
A rose, a flower.
Yes.
Flower is a living tissue.
Even though.
So living tissues contain multiple things. So plant is living, right? Plant is made up of cells, right? Cells have liquid in it, right? This liquid contains multiple things in it, like salts, like glucose, like water, like minerals, right? So yes, the living tissues, all the living tissues contain mixture.
Okay.
Okay. So your South, why your hand is still up? Ali, this is a last warning to you. Yes, Ali, what do you want to ask? The last warning, if you do that again, you are out of the class and I will report it to your parents. One student has left, so I will mark the attendance at the end of it too. Okay, so there's a term used, solution. What is a solution? Solution is basically, you can say, a type of a mixture in which you can say the ingredients are properly mixed. You cannot see the ingredients now. Like if you mix sand and water, you can see the sand at the bottom. So it is not a solution. But if you mix sugar and water, right? If you mix sugar and water, you can not see the sugar now if you mix it properly. So it is a solution. If you mix salt and water, you cannot see the salt now. It is a solution. If you can't see the ingredients in it, it is a solution. Okay, there are two components of solution, two parts of solution. One is called solute, another is called solvent. What is a solute? Solute is a thing that is being dissolved, or usually that is in a small quantity, relatively small quantity. Rehan, I will come to you in a minute. So, solute is something that is in the small quantity. Like Jawad, you are out now. Where is Jawad? Okay, who has raised his hand? Basil. Yes, Basil.
Did we talk this yesterday?
Yes, we did, but I'm basically revising it because were interrupted in the middle of the lecture, so I have to repeat everything so that everyone could understand what is about at the end. Okay. So now Tariq.
Sir,
Yes, Tariq.
there was two Jawads. I saw two Jawads.
Yes, I removed both of them.
One Jawad was sitting and the other Jawad was writing and doing stuff.
Yes, I removed both of them. Okay. Yusuf Jabir.
Mr.
Yes.
The water, it is mixed because oxygen and the hydrogen, if we mix it, it will be water. So
Yes, you are saying water is a mixture?
yes.
Look, if water was a mixture, it means that you can separate the oxygen and hydrogen. Can you separate the oxygen and the hydrogen? If you have two gases, like carbon dioxide, hydrogen and oxygen, two gases, right? If you have two gases and you mix them, it creates water. You were using two gases, and it converted into a liquid. You cannot drink oxygen, you cannot drink hydrogen, but you can drink water. You have made something new, a new matter, a new type of matter, right? This is water. But if you see the examples of mixtures, like salt in water or sugar in water, all these things, when you see, what are these things? These things can be separated very simply, and their taste change, but their physical properties change depending upon the amount of solute that you're adding. Solute is a component in the solution that is in a low quantity, and solution that is in the high quantity. Like if you are mixing salt in water, the salt is solute and the water is solvent, right? So if you put more solute, like more sugar, the solution will be more sugary or more sweet, right? If you put less sugar, then the solution will be less sweet. It does not depend. It is not the case with the water. If you make a simple hydrogen and oxygen, if you mix hydrogen and oxygen, it creates water. It does not matter how much hydrogen and oxygen you put together, their taste will always stay the same. Okay, their taste will always stay the same. Yusuf Jabir, does that clear your point?
Yes.
Okay. Lower your hand then. Rehan now.
Sir, what if we mix ocean and sea? What will happen?
Ocean and sea are already are mixture. Already are mixture because ocean also contains the salt, different types of salt in it, and the sea also contains the different types of salt. Right? So you are basically mixing two different mixtures together. Right?
Okay.
So if you are
Yeah.
mixing, it's like you are mixing the sugar and water solution, then you are mixing salt and water solution together. Basically, you are mixing two mixture together. Where is Nasser now? Nasser. Where is Nasser? Nasser, today I let you in. If you change your name or write anything, you will be out of the class permanently. I will not let you in the future classes and I will report it to your parents. Understand that?
Okay, Mister. Okay, Mister. My Wi-Fi, Faisal, no Wi-Fi, and
I don't care.
go bring Wi-Fi.
Okay, you are using internet. That is why you are connected to it, and that is why I'm listening to you. Okay, then silent. Don't make lame excuses. And this is the Saad King. I think this is, by the way, I'm the king. Rename yourself, otherwise I'm removing you in a minute. Okay. If we come back to this one, the slide. So remember these two things. Solution is made up of two things: solute and solvent, right? Solute and solvent. If I give you an example of a solution like salt in water, salt is solute, water is solvent. Salt is solute, water is solvent. The thing that we have to mix is solute. The thing that we have to mix is solute. And the thing that is dissolving something in itself is solvent, like water. If you mix sugar and water, the sugar is solute, the water is solvent. Okay? So let's go to the next slide. I talked about these two parts, solute and solvent. In solution, the substance that is dissolved is called solute. The substance that does the dissolving is called solvent. Okay, so we have talked about it. Solubility. Now this is very interesting. Solubility is the ability of any solvent to dissolve something. Right? So if we talk about salt and sugar, they have their solubility. They are soluble in water. They are soluble in water. But if I talk about oil, it is not soluble in water. It is not soluble in water. But what about sand in water? Sand is also not soluble in water. So we will say it is insoluble in water. But what about alcohol in water? Right? Or oil in water. The oil and alcohol are soluble. So anything that is, you can say, that can dissolve into something, it will be called soluble substance. and that does not dissolve or that does not mix up, it will be called insoluble substance. Okay, so I have given you multiple examples. If sugar and salt can mix in water, so they are soluble substances in water, right? Sand or stones are insoluble in water. They are called insoluble substances. Nasir, don't raise your hand unless you have a point to say. Okay. So what else? Now let's go to the next slide. What is solubility? Solubility is a measure of how much solute can dissolve in a solvent. How much solute? Remember, solute is something that is being dissolved. How much solute can be dissolved in a solvent? So let me paint a picture for you. Very simple picture in the mind. We have a glass of water, right? We have a glass of water, and we are trying to mix sugar in it. I put a single spoonful of sugar in the water and mix it. I gave it a one. I was swirling it in for 1 minute, and then it was mixed. After 1 minute, then I thought, no, it is not that sweet. I want more sugar in it. I put another spoonful of sugar in it, and then again I tried to mix it, and it was mixed after a few minutes. Then I put another spoonful of sugar and tried to mix it. It took a very long time, but it got mixed in the water. Then I put another spoonful of sugar. Then it will not be mixed. Okay. Now the water is saying enough, man. You are putting way too much sugar in me. Okay. Now my limit has been reached. I can't dissolve any more sugar. Right? The water's limit has been exceeded. The data limit has been exceeded. There is no more space to dissolve any more sugar in it. So this is the solubility. It is how much solute you can dissolve in a solvent. So in a glass of water, if we can dissolve 3 spoonful of sugar. This is its solubility. 3 spoonful of sugar. Let's say it has a 3 full spoon of sugar contain like 50 grams of sugar. So we will say 50 grams of sugar can be dissolved in this glass. This is the solubility of this glass full of water. Understand? How much solute can be dissolved in a solvent? How much solute can be dissolved in a solvent? This is the solubility. The solubility depends also. Let me give you a very interesting example. I think you might have heard of it before, and I think I explained it yesterday too. That if we increase the temperature, of the solvent, we can dissolve more. We can dissolve more of the solute, right? If we have, let's say, 2 glass, one is very cold, glass full of water, one is very cold and one is very hot, right? One contains the boiling water. The cold water will dissolve, you can say, small quantity of sugar, but the warm glass of water will dissolve very high amount of sugar. So we basically have the two same material, two same solvents. Both of them are water, but hot water solubility is higher than the cold water solubility. Hot water is dissolving way more substance than the cold water. Okay, so the solubility of the hot substances are usually higher than the cold substances. Remember that. Hot things can dissolve more, cold things can dissolve less. Okay, salt is a soluble substance, but sugar is more soluble than salt. This is just a fact. The salt dissolve, you can say, at much slower speed, and you cannot dissolve much of the salt in it, but you can dissolve a lot of the sugar in it. Solubility of most solute increases as temperature increases. That is the point that I made. If we increase the temperature, more solute can be dissolved in it. Okay, I hope you understood by the. Okay, Rehan. Where is Rehan? Rehan, you have lowered your hand again. Okay, let's see what else. Okay, let's do simple. There's a simple experiment. Bring 2 cups, put the same amount of water in both, then put 5 spoons of sugar in 1 cup and the 5 spoons of salt in another, which is dissolved more. Salt to sugar, you will see the salt will dissolve less, but the sugar will be dissolved more. You will see the sugar will be almost dissolved completely, but the salt will still be remaining. You can do this experiment at your home too. Now let's move to the next experiment. Bring 2 cups of water, one cold and one hot. You can do that experiment too at your home. Then put 1 spoon of sugar in the cold water and then next put 1 spoon of sugar in the hot water. Where did the sugar dissolve more, in cold water or the hot water? You will see in hot water it will be dissolved much more quickly, but in the cold water it will take some time to dissolve. You will see that. You can do that experiment. Then separating mixture. Okay, we can separate mixture. There are different techniques. One of the simplest technique is the filtration. We use a simple filter paper, right? Like you can use a cotton too, or anything that is porous, that has small holes in it. Okay, you can use filter paper or a cotton, a piece of cloth, or anything that you have at your convenience. So what we are doing, that we have a mixture of like sand and water, right? We have a mixture of sand and water. Then what we are doing, that we are passing this mixture through. We are passing this mixture uh, through the filter paper or the cotton or the cloth, piece of cloth, whatever you have. Right? What will happen, that the sand will not able to pass through the cloth or the filter paper, but the water will. So you will see the water will come out of the filter paper, but the sand will stay at the top of the filter paper. It will not pass. Right? Another example is the separating mixtures of magnetic nature. Right? If you have anything magnetic, right, anything made up of iron or anything that is magnetic, right, you can separate it out from any non-magnetic substance. Like if you have a mixture of two things, sand and iron dust. Iron dust is actually the thing that you're seeing here in the dark black color. It is called iron dust. What is it? It's basically iron, very small particles, right? Very small particles of iron. You are mixing two things, sand and iron dust. Whenever you mix these two things, you can easily separate them out. You don't have to look for each particle to collect it. You just easily or simply pass a piece of magnet over it, and all the magnetic substances or all the iron dust will be collected. So this is very easy to collect any magnetic substance from the non-magnetic substance. Then by evaporation, I told you about this, that if you heat the mixture of salt and water, simply what will happen, that after some time the water will evaporate, but the salt will remain at the bottom. This is the third technique. We talked about three techniques now. One is by filtration, by using the filter paper. Second is separating mixture by using magnet. The third is by boiling or putting the solution in the hot environment. So the water will evaporate, but the salt will remain at the bottom. Conservation of mass during physical change. Mass stays the same. This is a very interesting thing. It does not matter we are making any physical change, but the mass will stay the same. Like if we have 100 gram of water and we are mixing 10 gram of sugar in it, 100 gram of water and 10 gram of sugar, what will be the mass of the solution? It will be 110 gram. The mass stays the same. If we are mixing two substances, the mass of the mixture will be the sum of these two substances. Like if we have 50 gram of carrots and 50 gram of spinach, you are mixing these two things, then the volume, or sorry, the mass of the salad will be 100 grams, because you have mixed two simple things. You just add the mass of all those things and you will get the mass of the mixture. This is the conservation. Conservation means to keep it same. Okay, conservation of mass during physical change. Okay, we talked about this example too. Okay, this example again. If you have 10 gram of salt and 50 gram of water, what is the mass of the solution? Simply 10 plus 50, it is 60 grams. Okay, this is it for today. Now, if you have any question, you can raise your hand. Or here is Basel. Where is Basel? Basel. Yes, Basel. Basel, I can't unmute you. Why is that?
Mr.
Yes, Basel.
Mr. We finished.
Yes. Alhamdulillah.
Mr. If we have 100 kilogram of water and we ice it, and we freeze it, what will happen? It will be how much gram? It will be the same.
Yes, same. 100 kilogram.
But I thought the solid is
Heavier
if
than
we
what?
if we
Liquid.
yes.
No. Actually, the mass stays the same. It does not matter because we are using the same thing. It will have the same number of particles in it. The
Because
weight.
we do not add anything.
Yes, we did not add anything. The particles, if the number of particles or the types of particles stay the same, then the mass will stay the same. One thing that could be changed is the volume. Solid occupies more space. Ice occupies more space than the water, than the liquid water. So the volume could be changed, but the mass will stay the same. So we are talking about the conservation of mass. The mass will stay the same. Yes, Marwan now. Marwan.
Mr. So I don't understand the solubility again. Can you say it?
Which thing?
Solubility or
Solubility.
yes.
Solubility is the ability of a substance to dissolve something, right? If we have water, it can dissolve sugar in it, right? It can dissolve salt in it. It can dissolve other things in it. This is solubility. And also, how much can it dissolve? Can it dissolve 5 spoonful of sugar? Can it dissolve 100 spoonful of sugar? The number or the amount of sugar or any solute that it can dissolve, the amount of it, the number of it will be called solubility. Like if I have 1 liter of water, how much sugar can it dissolve? Can it dissolve 100 gram of sugar? If it can, then it is its solubility. Marwan now.
Yes.
Do you understand now? Okay, now I'm marking the attendance again. So few of you have left. I think 3 of you. Yusuf Anas, where is Yusuf Anas? I don't see Yusuf Anas here. Yusuf Anas, if Yusuf Anas is here, then raise your hand. If he is not here. Okay. Then Yusuf Jaber is here.